Hello, I'm back for the second episode of GNU Linux Game Hacking. As I said in previous episode, in this episode we're going to focus on reading and writing to memory from the file we are going to inject, so from the code. Now, if you know a little bit about modern processors, they have this thing called virtual memory, and virtual memory has some sort of permission system. You can designate parts of memory to be read-only, to be executable, to be writable, and you can do a lot of stuff. And by default, for security reasons, the code is always read-only. You cannot modify it. That's where comes mprotect. Mprotect is a very nice function from the posix library that allows us to change the protection of some part of memory. Now, as you can see, the prototype sounds very intuitive. You have an address, you have a length, and then you have a protection flags. This sounds pretty easy to do, but there's a catch. You have to align it with memory pages. This sounds a little bit of a pain to do, but I will show you how this can be done very easily. So I will write this function prototype. So we need a function that returns something, which is I will call it get page, so get the page boundaries, and I think we should have it return something like a pair of std uint ptrt. We'll actually use this as my pointer type throughout this tutorial. I think it's rather intuitive. You do not have, it simply means an address. It does not really mean how far, if you have some pointers to pointers to pointers and stuff like that. If you were to use void, then you'd have a tons of symbols like this, but by using std uint ptr, it really means that you want an address. No matter what it refers to, it's just an address. So we have get page, so the address, and the size I want to make writable, of course. Now there's actually a thing here, is that the block size, I don't know if it's specified in this manual, but there's actually something to get the block size, page size, sorry. It's actually there's actually a C library function. So that should be sysconf underscore sc underscore page size. So this gives us the page size. I think it's 124 on my system. It should be the same basically everywhere. Oh, yes, okay, yeah, that's right. I need to include this /m. I think that's it. Oh, maybe not. Did the manual said? Okay, man. All right. Anyway, I will maybe find what's missing next. Then we do some very simple arithmetic. So uint return equals to address divided by the page size. Oh, this is actually static. I did not say it, but it should be static memory. Does not really change because we're in a C++ file global scope. But anyway, it's page size. So this is simply getting the quotient. It's ADDR minus the reminder. So remove the reminder if you want to divide it by page size. This is a kind of a common practice. We could have used like something like this. You could have used ADDR minus something like that. ADDR page size. But anyway, this is not division, it's a quotient, okay, because it's they're both integers. Anyway, then we have en, and that's right plus len. And yes, this is a little bit tricky. because sometimes we are going to be exactly at the boundary of a page, and so this happened. So this is when we're not at the boundary, we're inside of a page, and so simply do this page size. We increase n, but if we are at the boundary, we do not increase n, so page size. This is rather important, because when we are at the boundary, we don't need to increase it furthermore, so just saving a little bit, but eventually if we were to do this right here, would not be a problem. Return ret and times page size. So yeah, I just said we're just doing some sort of rounding stuff, just as we did it here. Okay, so then we have our function, and there's actually something that I will be doing in this series, which is that I will try to handle exceptions. Not really handle, but at least throw when they are when we have some problem. I will throw, and I will give some sort of meaningful message to say where it happened. This is important because it can help you a lot into debugging later your cheats. So here I write something like if len equals to get page attr len. Okay, so let's just think about it. We make a function called void make writable. Okay, well, of course I will take these, you know. And yeah, we're gonna do it. Okay, we'll just give them some sort of different names so that they don't really mess with the rest. So void address, reinterpret cast void of the address, then the len, and then we have the protection flag slash prot underscore. So we're just gonna give every protection because it's code that we're going to modify. We need to give it the prot exec, then the prot read, the prot right. On some architectures, if you say prot exec, you do not need to say prot read. Here on I think on this one I need to do it. Yes, then I say if. So basically if this fails, this returns -1. So if it fails, then I will throw some sort of exception. Make writable. I think this is a good practice that we should take on very early. To throw exceptions when there's something wrong that happens. Oh, by the way, there we go. So now we have this function. We can make any memory address writable. Okay, so I'm back a couple minutes later. I figured out it would be a good thing to do to have to give you to load and unload a script. So they are a little bit I'd say they are a little bit more complicated than what we did yesterday. So this here is, you have the attach, set DL open, call DL open, detach, quit. Then I added a little bit extra features, which safety feature, which I'm going to talk a little bit about later. I also added just a bunch of stuff to print in red, to check that it is not already loaded. And here you just have to set the name for the library you want, and here is the PID of the game process names. Okay, so just a couple of safety features, like do not inject if there's no game, do not inject if it's already injected, etc. Then here, as you can see, there's two more instructions. There's B, SDLGL swap window, and C. These two lines indicate that what we want to do is to, when we inject, we want the code to stop when it reaches this function, just like we did in Cheat Engine yesterday. The reason for this is that this function is called every frame, and there's actually some good chance that we might be modifying the opcode of this function when we are injecting, and this would result in a crash. This somehow fixes it a little bit, but it's not really, it's not, sometimes you will still have crashes because it's actually running in a thread. But this, I believe, negates a little bit of it. You can remove them if you don't like it, but I think it kind of gives some a little bit of safety. And then there's the unload script. This one is much simpler than the other one. So you have PID, etc. So there are not the same safety as there were in the load script. But anyway, so yes, attach, DL open, DL close. Oh, actually, I don't need this one, but yeah. Then you actually need to call. Oh no, yes, okay. So you need to call DL open to get the handle, and then you need to close twice. I will talk a little bit about DL open and DL close. But every time you create a DL open, basically there's some sort of counter somewhere which counts the number of time that a library has been opened, and every time you close it decreases, every time you open it increases, and if you get it to 0, then this library is deleted from memory. Therefore, you can inject it a second time, but you can inject the modified version with the same name, and it would be okay. Now I will talk a little bit about these functions because they are the function that we're going to use in C++ code to get the address of memory functions and variables. Alright, so I'm back into the code. I opened the manual for Dlsym, and as you can see right into the code, I'm using DL open, DL close, and Dlsym. So what I do is that I open this library to get the handle for it, which is the SDL library name. If you don't know how I obtained the full name, you should be looking into proc PID maps. So I will be showing you. Just have to type something like cat proc PID of Svenkoa/maps. Then you have Svenkoa is not running, but then it prints you a bunch of entries, and it tells you the name of the libraries. So this is the full name. Then with Dlsym, what Dlsym does is it takes in a handle, which is the library handle, which we get right here, and a symbol name. Here it's SDLGL swap window, and it returns the address of that function. Now if I run the game and see what it gives me, the address should match that we get by using Cheat Engine. Alright, so I just run the game. And the address it gave us is this one, so it's EF8E96FB. And if we go into Cheat Engine, into the GL swap window function, what is its address? EF8E96FB, which is the same as that given by Dlsym. Now we have the function address. Of course, yours is probably going to be different because I talked about memory layout randomization. But with this, we can efficiently get almost all of the symbols that are present here. I said almost because Dlsym is only able to get the symbols that were explicitly exported by the compiler. If there were some static function, that might still, you might still be able to get their address, but it would not be possible with Dlsym because it was not made for this. You might remember from previous episode, this is the SDL swap, SDLGL swap window function. This is like the first bytes of it. Okay. So as I said, we need to have the first 5 bytes taken away and replaced with our own instructions. So by the first 5 bytes, what I mean is is that we want to replace them with a jump, which this is the opcode for a jump. And then here we need to make an offset that's going to be an offset to our own function. So what we are going to do is called the detour, sometimes called a hook. And this particular type of hook is often called trampoline hook, because not only are we going to execute our function, we are going to jump back to this one right after so that we can finish its execution. The thing is that doing it is a little bit technical, and I wrote a helper for it. Now I don't really need you to just copy paste without understanding, but this helper I believe is a little bit simple. But we could do it manually, but there's a little issue, which is this one. As you can see, as I said yesterday, we have to take out this one, and this one is a little bit different from the others because the value that it gives depends on where it's being executed. Because as I just said here, this one yesterday, we found out that it was moving the instruction of the address of the next instruction, which is this line, into RBX. But if we move this to another function, then it will give the address of the instruction that's after it, but not this one, and therefore this will give wrong result. But what we also did yesterday is that we replaced it with a move instead of a call, because they actually take the same amount of, uh, of bytes, and so this was actually kind of a clever and easy way to do it. So that's why I wrote this trampoline hook helper, which you can just use. I will put a link in the description so that you can download it. It's just a couple. It's less than 100 lines, but I think it's just very useful. And writing it in a video would be rather long because it took a lot of time to get it right. All right, this is it. I created the tramp h++ file for the trampoline utility. So I moved the get page function here. I wrote this function. I can't remember where I took it off. I know it's not me, but this is an ELF utility to get. Actually, it should be ELF32. Change. Yes, I'm just going to change it, but 5432. Yes, okay. So, there we change it. It doesn't really matter anyway, but basically this, you take an address and it gives you the protection flag that are in this address. This is just to make things a little bit cleaner, because while we can set a protection address, when we are finished, we'd like to set back the original flags correctly, and this is a way to kind of get them before we modify them. This is not important, but you might believe that maybe in the future some anti-cheat will be checking if your if the memory protection flags have not been modified. You know, it's just it could be that some anti-cheat might do this in the future. Anyway, this is the trampoline class. So I put it into a class so that I can use the fact that when it gets instructed, we release things. Basically everything gets back to normal. Okay, so there are three things here. So there's the size of the detour. So that's the number of bytes we are going to remove from the original function. This is the address of the original function, and this is the address of our function. Okay, so you can see here fn is the original function, hk_fn is the detour, len is the length, and then we have some function here which is the patching function, because as I said earlier, we actually need to modify those bytes right here, and so we pass in a patch function which can do a bunch of stuff. So just a little check, if the size is smaller than 5, then we can put the jump plus address and so therefore we throw. Then we store the flags, .improt, and we make the page, the address writable, so address length, and we make it writable using the get page that we wrote just earlier, the mprotect. Now we copy the bytes, so we copy the bytes that were in this address, and we copy it into the gateway. And in the gateway, we call at the end of it. So the gateway is, I think it's initialized with a little bit more of space. Where is it initialized? Yes. Okay, gateway length, which is m length plus 5. So that's the length of the number of bytes we are taking, plus a little bit extra at the end. Okay. And so at the end, we put a jump near, and then we put the offset that we're gonna be jumping to by using this. So m address minus m gateway minus 5 is just the calculation. Okay, then we call the patch function right here. By default, the patch function does nothing, as you can see here. Then in the original function, we replace all the instruction with nops, this and ops, because there are sometimes, and here is a good example, because we are going to take more than 5 instructions. Actually, we are going to take more than 5, so we're going to take 1, 2, 3, 4, 5 bytes. Sorry, not instruction, but bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to take 9 instructions. So we are going to write 9 nops, which just do nothing if they are ever executed. But this should not be the case actually. But anyway, I just write them because I think it's kind of elegant. And then at the beginning of the function, we jump, and we jump to our own function in which we do our stuff. Then we revert back the original protection, and this one is very important because memory allocated with new right here is by default not writable, at least according to the standard, I think. To the POSIX specification, it's not writable by default. Executable, yes. And so we make it executable. And that's it. That's now the detour is done. And now there's a release function. So release reverts things back to normal, and it's important to have it done correctly because we can release, remove the cheat, and without restarting the game, we can re-inject a second time, and things should be working without the cheats. If we just do this and never release, if we were to remove the library from the game, then the game would crash because it would try to execute some memory that no longer exists, so therefore it would instantly crash. So that's why we need to have the release done correctly. So there we go. We have a patch function which should do the opposite of what this one did. If it did nothing, then this one does nothing too. But it's just a matter of like setting things back to normal. Okay. So we start by storing the protection flags that are on the address. Just as before, we make it writable. We write the original bytes that we have that are stored in the gateway actually. We run the patch function, and then we revert back to the original protection flags, and we free some memory. Now this could be kind of optional, because if you are using Trampoline, then you are likely hooking at the beginning of your program and dehooking at the end, and so this is not really necessary. But because if you use later some sort of analysis tools, then it will probably yell at you if you don't do this. But it's not gonna create some memory leaks, because this is in any way going to be deallocated when the library is removed from the game. Now there's a standard destructor which calls release with no with no um yes with no patch function. Now this if we were to call this release with no patch function, so if we're as I said a little bit before, the patch function replace this call with a move, moving the address. And if we don't unpatch it, then what it's going to do is that instead of a call here after we remove the cheat from the game, it's actually going to have a move, but there should not be any issue with that because it's the same size and stuff. And so this actually magically makes it so that we don't have to call release with anything special in it. Okay, and now is the get original function. So you give it a function class. So for SDLGL get a swap window, you just go to the SDL documentation. Actually, I might have it. Yes, okay. Swap. No, I don't have it. Swap window. But if you were to look into it, then you'd have some function prototypes, get some int, SDL, etc. So you can easily get the function here that you need to type in the function type. You need to type right here, and basically just returns a reinterpret cast. This is useful because you will need to call the original function in your detour. If you don't do it, for instance, this is a draw. If you don't draw, then you're only going to be seeing what you draw, but not what the game draws. And well, this sounds kind of dumb, but for sometime you might want not to call it. For instance, if it makes a check somewhere, you might want not to call it, or to call it with a special sort of argument. For instance, in Counter-Strike, there's a file that checks your file system to see if there's any modified files from CSGO, and you can modify the file that it's currently checking so that it actually always says that your files are not modified, and with this you can modify player models and stuff. Well, this is a little bit off topic, of course. So anyway, we have the trampoline function done, and I will actually call it so that we can use it with this SDLGL swap window. And by the way, this code here, I will write it because DL open might returns null, as we saw in the first episode, if this address here, if this library here does not exist, or something else happens. This too might return null, so we have to be careful about that. Alright, so I'm back a couple minutes later. I actually, so I just did what I set up would do, which is I would handle the possible errors in getting the symbol address. So I handle every possible error I think that could happen. In any way, I just made it into a function to make things a lot simpler. So there it is. It's a function. So swap window equals to new. So I made a pointer here. So this is important because in the detour function, we need to call the original function. So I need to have a swap window pointer. So that's actually something you can do to put it here. Maybe what you could do is to use some sort of trickery with lambda, but I don't think you can execute a lambda by its address. Okay, no, what? Yeah, but you shouldn't. No, okay. So this is probably the best way to go. And here is some sort of storage for. It's a storage for the patch function. So once again, here we have to replace this with a move. So this is the move. This is the instruction to move into EBX. And what we move is the address of this instruction here, right here. And so we get it. So the address itself is ADDR plus 9, which is 1, 2, 3, 4, 5, etc. Here it's where ADDR plus 9 is, and we just move it into it. Okay, so now that I've done this, I have not done anything about the cleanup. but I just explained a little bit that if we just let the cleanup call the default destructor, that is this one, then we should not have any problem. Okay, so I have the game running. As you can see, it's running right here, and the detour function just calls just just prints stuff into the console, so it should be spammed every frame with a frame stuff. Okay, so load. So I call the load script, and now as you can see, it's spamming. Can you quit the game quickly and hack and load it? So now that we have this, what we need to do is draw onto the screen, and this will be the topic for another episode. And I will give you a little bit of a teaser. I will actually explain how you can use ImGUI, which is a very complete and very easy to use library. The only difficult part is setting it up, but I will go through this in the next episode. Goodbye, everyone.